Okay, a question here talks about a side compartment flooded as a result of collision, and we need to sketch the vessel's statical stability diagram showing the effects of the resulting reduction in freeboard and angle of list. And then part B, the countermeasures if we do end up flooding. So as it says there straight away, the two effects of the side compartment is going to be reduction in freeboard and the vessel listed over. So as we put here, in the case of bilging a side compartment, the vessel will list due to the flooding on one side of the vessel, and we have the freeboard as well. So the list, immediately we have a listing moment curve. This if you like, you would draw a GZ curve. Well, this is simply a moments curve, which is GZ times the displacement of the vessel. So the values along the y-axis are W times GZ rather than just GZ. So we draw the heeling arm curve, or the listing moment curve. There's our original GZ curve, or this one here, the original writing, or excuse me, sorry, the original writing moment curve goes like that. That happens there, the listing moment curve, so we lose that stability all in this shaded area here. That's all lost due to the side flooding. Because the freeboard has been reduced, that means that our deck edge immersion happens quicker, and because that happens quicker, the curve recurves quicker rather than later on the original curve, and because that happens, we lose all this stability due to the reduction in freeboard. Notice that only starts from when our deck edge immerses. Notice initially the GZ curve, or the moments curve, is the same initially. It only changes, it only goes the other way once the deck edge immerses. So all we've got left is that residual stability there. So make sure you draw the curve the same initially, and it just branches off. So the effects that we suffer, well, obviously reduced dynamical stability at all stages, that's the only stability we've got left. Reduced range of stability, angle of vanishing stability, and of course the maximum GZ. So that's all the effects that it has there. Now the countermeasures that we could perhaps do: close watertight doors, use our pumps to remove water from the flooded compartment, take measures to restrict the ingress of water. In other words, the other vessel may well stay in place to stop the ingress of water, or some sort of collision patch. Cross flooding, so balance the other side to bring the vessel upright. Movement of weights transversely could help as well. Balance, so that's if you're hit at the side. Balancing aft so as to raise the forward section of the vessel, or movement of weight, again to achieve a similar effect. And when combined with the cross flooding, you may well end up with the hull being raised above the waterline. Removal of weight, particularly for the upper parts of the vessel, like a swimming pool. Taking dead weight off to other vessels. Shore up internally, so that we ensure that we don't get any loss of adjacent compartments, so make sure that the ingress of water doesn't go further than the initial damage. And if all else fails, beach the vessel. While you're doing these measures, you would have reference to your ship stability data, and that data gives you guidance if this sort of circumstance arises.